In this problem, we have to solve a given equation which has 4 distinct roots of equal moduli. Let us solve this in 2 cases. In case 1, let us take 2 real roots and 2 imaginary roots. Since these are roots of the given equation, so x minus these roots are factor of given equation. So after solving this, we have got a new equation. Now comparing the new equation with the given equation, we have got that case 1 is not possible. That means the given equation cannot have 2 real and 2 imaginary roots. Now in case 2, let us take 4 imaginary roots. So x minus these 4 imaginary roots are also a factor of the given equation. Solving this like the previous one, we have got a new equation. Similarly, comparing this with the given equation, we got the value of r from the constant part. From the coefficients of x, we have got cos theta 2 equal to 1 by 2 minus cos theta 1. From the coefficients of x square, we have got the value of cos theta 1 and theta. Using these values, we got cos theta 2 and theta 2. After putting all the values, we got the required equation that are I minus I, 1 by 2 minus I root 3 by 2 and 1 by 2 minus I root 3 by 2. So in this problem, we have to find 4 roots of 1. Let us take x equal to 1 to the power 1 by 4. We know that the polar form of 1 is cos theta plus I sin theta. Comparing 1 and the r theta form, we have got r cos theta equal to 1, r sin theta equal to 0 and theta equal to 0. So x equal to cos 0 plus 1 sin 0 whole to the power 1 by 4. There are 4 distinct values of x and they are cos 2k pi by 4 plus I sin 2 pi by 4. Here k equal to 0, 1, 2 and 3. Putting the values of k, we got the required roots 1, minus 1, I, minus I. We have to prove the given trigonometric function by using de Moivre's theorem. So here we have take cos 5 theta plus I sin 5 theta by de Moivre's theorem. Cos 5 theta plus I sin 5 theta is equal to cos theta plus I sin theta whole to the power 5. Expanding the right hand side in binomial expansion, we got a new complex form. Comparing the real and imaginary part, we got the values of cos 5 theta and sin 5 theta. Now, as we know, tan 5 theta equal to sin 5 theta by cos 5 theta. So putting the values of cos 5 theta and sin 5 theta, we have proved the given trigonometric function. Hence proved. Let us solve this equation by Cardin's method. Here x cube minus 18x minus 35 equal to 0 is the equation. Now let x equal to u plus v. By cubing both sides, we have got one new cubic equation. Comparing both the equation, from the coefficient of x, we have got the value of u, that is 6 by v. From the constant part, we get u cube plus v cube equal to 35. Putting the value of u, we get 6 cube by p cube plus v cube equal to 35. Here, let us take v cube equal to y. So, after solving, we got a quadratic equation whose roots we have got 27 and 8. Taking y equal to 8, we get p equal to 2n minus 1 plus minus I root 3. Putting these values in u equal to 6 by p, we got u equal to 3 and 3 by 2 multiply minus 1 plus minus I root 3. So the roots are 5 minus I root 3 by 2 and minus 5 plus I root 3 by 2. Here, I am going to explain Euler's method. Now, in this problem, let us take x equal to root over p plus root over q plus root over r. Squaring both sides, we get x square equal to p plus q plus r plus 2 inside bracket root over pq plus root over qr plus root over rp. After solving this, we get equation 2. Now, comparing equation 1 and equation 2, we get the values of p plus q plus r, pqr and pq plus qr plus rp. Now let us take a cubic equation having roots p, q and r. By using the relation between roots and coefficients, we have taken out the coefficients of the cubic equation. Now we have observed that y minus 1 is a factor of this equation. So, after solving this, we got the values of p, q and r. Now we will arrange p, q, r in such a way that we get the value of root over p, q, r. So, here, the value of root over PQR is minus 2. So, the following combinations are only possible. So, the roots are 1 plus I root 2, 1 minus I root 2, minus 1 plus root 6, minus 1 minus root 6. In this problem, we have to find an equation whose roots are increased by 2 of the roots of the given equation. So, let alpha be a root of the given equation. Since the root is increased by 2, so y is equal to alpha plus 2. Here we get the value of alpha. Since alpha is a root, so replacing x by alpha, we got an equation and solving that by putting the values of alpha, we got the required equation. Let's solve this question. So here we have to find the roots of the given equation whose two of the roots are equal in magnitude but opposite in sign. So let alpha 1, alpha 2 and alpha 3 be the roots. Here a0 is equal to 2, a1 is equal to minus 1, a2 is equal to minus 18, a3 is equal to 9. According to question, alpha 1 is equal to minus alpha 2. Now, using relation between roots and coefficient, for a1 we got the value of alpha 3, that is 1 by 2. Then for a2 we got alpha 2 is equal to plus minus 3. Here, if we take alpha 2 equal to 3, then alpha 1 is equal to minus 3. So the roots are 3, minus 3 and 1 by 2. So here we have to show that A plus A transpose is a symmetric and A minus A transpose is a skew symmetric. So let A be a square matrix. Here the transpose of A plus A transpose is equal to A transpose plus A. Arranging this, we got that A plus A transpose is a symmetric matrix. Again, by transposing A minus A transpose, we got A transpose minus A. Arranging this, we got A minus A transpose is a skew symmetric matrix, hence shown. So here, let us identify that the given matrix is symmetric, skew symmetric or neither. Let A be the matrix. So after finding the transpose of A and minus of A, we got that A transpose is equal to minus A. That means the given matrix is a skew symmetric matrix.